The scientists around the world celebrated today as the discovery of what appears to be the God particle was announced. Named after a former University of Edinburgh professor, the Higgs Boson particle could help us all understand substance in the universe. The discovery is the biggest leap in physics for decades and fills a crucial gap in understanding the atom. Scientists at Switzerland's CERN made the announcement with Professor Higgs watching on.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement. For me, it's really an incredible thing that it's happened in my lifetime. It's taken...
To assess the significance of the discovery, we're joined by Edinburgh University's Dr Victoria Martin, Glasgow University's Dr Richardson Dennis and the TV science presenter Dr Bunhead. Welcome all to Scotland Tonight. Richard, you've been celebrating today.
Absolutely. After, sorry Vicky, but we went out to, we stopped looking at the permutations this afternoon, Chris and I did, because we saw that message come through that there was going to be champagne at the Higgs meeting this afternoon. So we said, oh, the heck, it's beer o'clock and we're getting out of here, submitted a job, and we'll give you results tomorrow.
Excellent. Well, I'm glad you've sobered up for coming on air with us in Scotland Tonight.
Well, everybody was wondering why I wasn't drinking much.
Well, I'm glad you didn't. Victoria, a great day for Edinburgh University, I'm sure.
Yeah, it's been very exciting at Edinburgh. We've been watching the presentations coming over from CERN, and I also had a very brief chat with Professor Higgs this afternoon on the phone, and he was very excited too.
What was he saying? And tell us very briefly about his time at Edinburgh University.
Well, he was at Edinburgh University for quite a long time, and while he was there, he developed this theory that we now call the Higgs theory about the Higgs boson. Today he was saying he was actually quite tired, listening to all the presentations, taking it all in, and all the media attention, obviously, that's been on him. But he was in very good spirits.
And he spoke about it being a highlight of his life. And he's an elderly man. He's in his 80s, of course.
Yes, he is.
A big day. So, Dr Bunhead, a lot of people, and I've been spending all day trying to work out what this means, and I've failed miserably. So can you put this into context for me?
It's one of those things that if you go out on the street, you don't see people waving bunting like they have been with the Queen. And the significance really is missed in much the same way as the significance was missed when X-rays and radioactivity came to the fore a century earlier. We won't know the significance of this for, I don't know, decades from now. And trying to explain something like this, as you see by the whole raft of different analogies that have come forth to try and explain it. And I heard one person say, and you correct me if I'm wrong, but if you think you understand quantum mechanics and the quantum world, you really don't understand it, because it defies everything that we're familiar with.
Yeah, one of the things I enjoyed in teaching and learning, they asked us at one point, they had this exercise where students were supposed to write down their emotions. And I said, is it a good or a bad thing if I'm teaching quantum mechanics and they've written down confused? I take that as a good thing.
That's a good thing.
Yes.
So it's good that I don't understand any of this.
No, another time I was actually teaching in a course, and I was talking to the other lecturers, and I said, I don't understand how this is working. I am so confused. He said, yes, you have a sophisticated level of confusion. The students have a less sophisticated level of confusion. So it's matters of confusion. And that's actually the thing that's so fun, because there's these moments when suddenly pieces fall together, but there are a lot of other pieces that just aren't there.
And you were involved in the research. What did that involve from your perspective?
It involves a lot of late nights. There was a joke that went around recently saying, I've installed this one computer program we use so many times I can do it in my sleep. It means designing the thing in the first place. I started working on this in 1991. And looking at the simulations of these kinds of things and trying to understand how to put the whole thing together. So that's the part for us that really seemed to be critical. It's getting the excitement going in the group. I mean, we had a great time this evening. Of course, everybody was excited to be there. They're all having a lot of fun doing it. And now we've also got the attitude of, hey, let's go measure the properties. That is what we've aimed our group to do, and that's what we're going to be doing. And Victoria is actually on our editorial board. That was about earlier.
So, Victoria, tell me, what did Professor Higgs, when he was at university, what was his idea then that had to be proved, essentially?
Well, he came up with this idea that we now call the Higgs field, or the Higgs boson. And it's a way, like you said before, to give substance to the fundamental subatomic particles that we've seen in our detectors. But we didn't know today the reason that they had a mass. And they need a mass. If they don't have a mass, then they won't stick together and make things like atoms and make you and me. So that's the theory he came up with, a way to give them mass so they can stick together.
And you said, Dr. Bunhead, there were a lot of analogies. Is there one you could use that might help?
Yeah, I mean, I think of Higgs bosons as the burger particle, the cosmic burger. You read in the press, when I try to find an analogy, I always try to relate it to things people are familiar with. And all the time in the press, there's weight issues. Press are obsessed with people's weight. Some people are heavy, some people are not heavy. Why is that? Well, like that, I see physicists obsessed with weight, some of them, a narrow group, but they're obsessed with why some particles have mass, which people usually call weight, but we don't really mean the same thing if you want to get nitty-gritty about it, and some have no mass at all. And it's as if by associating with these cosmic invisible burgers, the bosons, the more you associate with them, if I'm right, the more mass you have. Now, you'll probably correct me on that.
No, I mean, actually,
don't do too much detail, please.
The statement about weight is hysterical because the big problem that had to be solved was this beautiful theory that was being put together by Glashow, Weinberg, and Salam, but they couldn't get over the problem that they couldn't give the particles weight. And so what they did was they put in this Higgs, and that's what gave them weight. And a lot of the actual technical term is that they ate the degrees of freedom and gained weight.
Ah. I didn't know that.
Well, don't worry about the degrees of freedom part.
Okay. Thanks for
it's the gained weight part I was getting at.
To me. And you said that earlier on the X-rays and when that was discovered, we didn't know how it could be used. So, okay, we might not know how this can be used. What potentially might it be used for?
Well, I was thinking, we were chatting back there, and you were talking about lasers, and I thought it was great. You said it was like a year before lasers came online and started having applications, and of course now people shine them at footballers, so they'll distract them. Now, lasers are sort of big, hefty objects, and we get them down to this small. The Higgs boson machine is 27 kilometres, so I think it's going to be a while before we shrink them down and we fire Higgs particles at footballers. But as you were saying, it's the actual mechanics of understanding how matter works that is going to give us these breakthroughs, not actually making a Higgs machine itself or something that's going to make a smaller device to make Higgs particles. It's understanding the mechanism of how all this stuff holds together that's really going to give us the breakthroughs, and we just have no idea what's coming. That's what's exciting.
And very briefly, Victoria, it would appear that at least the science textbooks do not need to be rewritten. There was some concern that might have to happen if this couldn't be proved.
I think they have to be updated now we've actually found something, found the new particle, perhaps the Higgs boson we're really looking for, but not rewritten.
Well, that's a relief. And so what further celebrations then, Richard, among the science community? How do scientists celebrate?
Well, we went out drinking and we have food and we do what the normal people do. We actually do breathe and eat and that kind of thing occasionally. I mean, there are some great jokes associated with people that don't, but if you've watched Big Bang Theory. But I think that we're just going to go on with the celebrations, but we're also going to do a lot of thinking. I was saying earlier that we're discussing what are the implications of this and what is it going to mean for the science. Yeah. How do we do it next? Right. And we just went to a blackboard and went, oh, this is what we're going to do.
I'll need to stop you there, Richard. Thank you very much indeed, Victoria, Dr. Bunhead. Thank you very much indeed.